Hello students, welcome back. As a final application of the definite integral, let's consider some area problems. Here's a graph of a function and find out the area of the shaded region. Here, the area means the geometric area. The signed area will be 0, as you can see from this. Negative and positive will cancel each other. So if you integrate from -1 to +1, you're going to get 0. That's not helping. Here's another problem. Again, if you integrate from -1 to +1, you're going to get 0. The signed area is clearly 0. Also, can you see that this is an odd function? So negative, positive part cancel each other out. So how are you going to calculate this? Well, we have to set up properly. The area should be the integral of 0 to 1 only. This part, the right-hand side part. X 1 minus x squared dx, and then we have to double it. You see, if you take this integral only, then you have only this area. You want this part as well, so you have to double it. That's the integral computation you have to do. Now, how are you going to calculate this? You're going to need some substitution. Y is 1 minus x squared. Clearly, that's the inside of this composite function. dy is -2x dx. Therefore, dx is 1 over negative 2x dy. And that's going to go here. All right. How about the starting and ending points? If x is 0, then y is 1 minus 0 squared, so it's 1. Okay, that's green. And if x is 1, then y is 1 minus 1 squared, so that's 0. So x is going from 0 to 1, then y is going from 1 to 0. All right, we are ready. Let's calculate this integral. So x is going from 0 to 1. Y is going from 1 to 0. And this is my y. And this times 1 over -2x dy. Okay, all right. So this is twice the integral. Y is going from 1 to 0. And then we have x canceling out, 1 over -2, and square root of y, or y to the 1/2 power, dy. Okay, this -1/2 and 2 will cancel out. We'll get negative of that. And then here we only have y, so there's no reason to specify the variable like that here. So we get That's integral computation. And let's do one further simplification before calculating the antiderivative. If I change this into 0 to 1, then I'll be able to remove this negative sign, and you're gonna get the final expression like this. Okay, alright, and then let's calculate the antiderivative value. 3/2 and then divide, and then that's going from 0 to 1. So plug in 1, 3/2, plug in 0, we get 0, so the area is 3/2. Okay, that looks good. Did I do this right here? Of course, I must have done it right here. Did I do this right just now? Let's check. Area set up, twice of this integral, and then we have this integration by substitution set up, starting and ending point of the integral. And then area computation is just the integral computation. In the end, you get 2/3. Next problem. A little bit harder, because the integrand, we have x cubed square root over minus x squared. So integrand is a bit harder. So this problem will be a bit harder. Let's see, the area is going to be 2, the integral running from 0 to 1, and then x cubed square root of 1 minus x squared dx. That's what you have to calculate. Sorry, this should be x cubed. As before, we are taking this as my substitution. Previously, I used, I think, y, so let's use some other character. 1 minus x squared. du is negative 2x dx. And then dx is 1 over negative 2x du. Okay, that's the main substitution, the inside. And then we get dx substitution here. So let's put those in. Okay. And this entire thing is now that's y, and instead of that, 1 over negative 2x du. Excuse me, I'm using u this time. And let's do this computation. See, this is red, red, and blue, blue, and this time I'm using method number 1. Okay, alright. Twice of the integral x cubed and u to the 1/2 power. Oh, I'm kind of running ahead as a matter of fact. X cubed and x cancelled out, and this becomes x squared. And then times 1/2, and that'll cancel out with this 2 as well, negative, and we have du Okay, that's what we have so far. So this x and that x cancel out, we have x squared left. And then this 2 and that 2 cancel out, we have just negative. Okay, one more. What is x squared? U is 1 minus x squared. If you calculate x squared, it will be 1 minus u. So we end up with this integral computation. And let's do one more. U minus 1, u to the 1/2 power du, because if I distribute this negative sign, we'll have sign change. Integral of u to the 3/2 power minus u to the 1/2 power. Okay, all right. Finally, let's calculate the antiderivative. Add 1 to the power, and then we need the reciprocal. Add 1 to the power, and then reciprocal. We need plot C if this had been a indefinite integral problem, but we're going to do definite integral later, so we don't really need plot C. Okay, let's go ahead and find out the area. That is twice of the definite integral, 0 to 1, x to the 3rd power, square root of 1 minus x squared dx. So this is the indefinite integral, this one here. Oh, excuse me. I did not complete this problem. Sorry about that. Copy and paste this thing. And then what is x? What is u? It's 1 minus x squared. 1 minus x squared. Okay, all right. Now, okay, that looks good. Copy and pasting this one here. 0 to 1. Oops. Okay, that's the computation you have to do. So plug in 1, and you're going to get 1 minus 1. So that's going to be 0. Plug in 0, then we're going to get 2/5. And then that's 0. So 1 to whatever power is just 1. And plug in 0, that's 0. 1 to whatever power is just 1. So 2/3. And what is it? 2/3 minus 2/5. So that's 5 minus 3, 2/15. Looks like that's the area, 2/15. So we want the antiderivative computation. And then you have to complete it. Get to the bottom of it. X expression back in, and then the fundamental theorem. Here in this notebook, you have the answer key written in the second method. Oh, you should have 4. Oh, yes. I forgot multiplying by 2. So it should be 4/5. Sorry about that. Multiplying by 2. Yeah, I got 2/5 and stopped there. Just this integral computation. Okay, check out the notebook for detail. And that completes lesson 13 and probably calculus 1, at least the required part.